So this is a problem again, that we want to find the Thevenin equivalent. That's a good practice. So in this case, we have our resistors, but even if you had inductors or capacitors, sinusoidal, that wouldn't make it right. You just find the impedances and just work on the impedances. But in this case, for simplicity, we just have resistors, and it's everything basically is in the DC. But the technique will be the same. So we want to find the R Thevenin and V Thevenin. So let me first start with V Thevenin. And because I see some current sources, I will use mesh analysis. Again, as you already know, there's not a unique technique for solving a problem. You can also do node analysis, you can do mesh analysis, but let's do the mesh. So this one, 12.5 amp, just put the whole mesh current as this because of this current source. And on this one, let's say it's I. And let me write the KVL. So this is the final detail. Let's write KVL on this mesh. So let me start from here. I'm going to write the KVL on this mesh. So 8 times I1 plus 9 V of X plus 2 times I1 minus 12.5 plus V of X. Let's do the 4 times I. So I1 equal to 0. And by the way, this is V Thevenin, open circuit V Thevenin, which is in this case exactly equal to V of X. So basically V Thevenin is equal to V of X. So this is V Thevenin, if I'm looking for it, and I1, I have to look at I1. I1, if you look at this, I1 is the current here. So basically, we can also say V Thevenin of V of X is 4 times I1. In other words, I1 is V Thevenin divided by 4. So I just replace I1 in that first equation. So this is my main KVL, and these are like the dependent, for example, V of X, what's that dependent voltage? Okay, so 8 times I1 should be Thevenin divided by plus 9 Thevenin plus 2 I1, which should be Thevenin divided by 4 minus 25 plus 4, again I1, V Thevenin divided by 4 equal to 0. And simplify 4 and 4. 8 and 2, basically, okay, so it's 2 Thevenin, and then so we Thevenin times 2 plus 9 plus half plus 1 equal to 20. So this is 10, 12 and a half. So V Thevenin times 12 and a half equal to 25. So V Thevenin is 2. Now to find R Thevenin, again, there are different techniques. One is to zero the current source. You have to basically remove this current source, and then you put the test voltage, Vs over Is. But I want to also practice the one that we look at the I short circuit. And then V Thevenin divided by I short circuit is equal to R Thevenin. So again, both of them work. And just as a practice, I want to do this one. V open circuit V Thevenin, which I already have, is 2 volts divided by I of short circuit. Okay, so let's therefore look at the I short circuit. And in this case, you had this current source. You had this 2 ohm. I have this 4 ohm. And then A and B, terminal A and B, and I just short circuit. And then the other side, 8 ohm and 9 V of X, and this is V of X. And I'm looking for this current I short circuit. Okay. Okay, now the nice thing here is that because I short this, first of all, V of X becomes 0. So V of X becomes 0. And therefore, and this one depends, this is 9 times V of X. So basically this becomes 0. So this is also shorted. And because this is shorted, I can just also remove that from the circuit. And this is also, as I said, this is also 0. So this is also shorted as well. So the network simplifies a lot. So equivalently, I can say I had this is what's left. What is left? This is 2 ohm. I have still the current source here, 12.5, but then that is removed. Still I have the short circuit part here, and then I have the 8 ohm. The other one is also that dependent voltage source is also removed because that's 0. Okay, so basically this is the circuit that we have, and we are looking for the I short circuit. So again, we can just do very simple mesh. This is 12.5 amp, and this is I short circuit. Okay, so let's do a very simple KVL here. Let's say 8 times I short circuit plus 2 times I short circuit minus 12.5 equals 0. That's it. So 10 I short circuit negative 25 equal to 0. So I short circuit is 25 divided by 10, 2.5 amp. This is I short circuit, but then R Thevenin is V Thevenin divided by I short circuit. V Thevenin was 2 volts. I short circuit was 2.5 amp. So this is what we get, 2 divided by 2. Oh. This is R Thevenin. Again, this is one technique. We could also do the other technique. We just zero the source, this one, you remove this, and then you put the test voltage. And we look at R Thevenin as Vs divided by X.